Let's do a sum based on similarity of triangles. What we have here is we have two triangles and they are saying, are these two triangles similar? If they are, justify the answer. How do we do that? If you look here, in both the triangles, we have only information about the sides. So one thing is very clear, if they are going to be similar, they will be similar by SSS test of similarity, right? But for SSS test of similarity, we need to find the ratios of the corresponding sides, 3 ratios, right? How do we decide which side is corresponding to which side? We don't know. How do we do that? How do we take the ratio now, right? Now, we cannot do the trial work, right? So how do we do that? I'll give you a trick on that. It's very simple. What you need to do is take the smallest side in triangle ABC, which is that, it is AB, and take the smallest side in that triangle, which one is that, it is QR. Take the ratio of this two, so that means it is going to be AB upon QR, and that is nothing but 2 upon 4 divided, reduce it, it is 2 ones are 2 twos are, that means we get 1 upon 2. That's the first ratio we got. Next, we took the smallest. Now we're going to take the largest there. So the largest here is going to be AC. What's the largest there? The largest there is PQ. Take the ratio of this two. So it is AC upon PQ. That means it is 3 upon 6. That means it is 1 upon 2. And that's our result number 2. We got this. So what is now the remaining one? The remaining one is the side which is here, BC and PR. So we write BC upon PR is equal to 2.5 upon 5. And this is very easy. 2.5 ones are, 2.5 twos are is 5, right? Or in other words, if you take remove the decimal, it is 2.5 into 10, and into 10 here, so it will be 25 upon 50, that is 25 ones are, 25 twos are, and we get that. So from this, what we can say is that in both the triangles, we got all the 3 ratios to be equal. That is AB upon QR is equal to AC upon PQ is equal to BC upon PR. That means now we can say, yes, both the triangles are similar. But the most important thing, what we are going to do now, that's very important and very critical. Whenever we write two triangles similar with the symbol of similarity in between, it has to be as per the one-to-one correspondence of the vertices. Now that is very critical. It's very easy when they are similar by AA test. Congruence of angles defines the correspondence of the vertex. But how do we do when it is by SSS test? Well, that's the trick which we have already learned one. This is the easiest trick, right? What we do is, out of the 3 ratios which are equal, take any 2 ratios. Pick up any 2 ratios. Now I picked up the first and the second. Now what you do is, look at the numerators of both and see what is common in them. What is common? A. So mark that. A and A, right? That is common. Look at the denominator and see what is common. What is common? You see that Q is common. That means that gives us a 1-1-to-1 correspondence. What is that? A corresponds to Q. That is defined. The moment you get that, believe me, the other two is done. Because if you look at the first ratio, what is remaining there in the numerator? B. What is there in the denominator? R. That means B corresponds to R. And the next one is C corresponds to B. But you don't want the next one, because whatever is, once you write the second one, whatever is left is nothing but the third. Isn't that? Yes. But this is the easiest way to do, right? What we did is pick up 2 ratios, any 2 ratios which are equal there. Common in the numerator, common in the denominator, and then that is what we get. Those commons are actually corresponding to each other, and the remaining one each ratio gives us the next one. So we get B corresponds to R, isn't it? So B corresponds to R, we write that, and the remaining one is what there is P, right? So that means we have this, and that means here both the triangles now are similar, and this is the correspondence. Now you will say, aren't we supposed to write the correspondence names of the triangles here as per the correspondence? No. Here we are just considering the triangle. We took the 2 triangles. Then we realized that yes, in both the triangles, these ratios are equal. So now the triangles will be similar, but they will be similar by this correspondence, right? And that is very critical. And this is how you do it when we are doing it by SSS test of similarity. Easy, right? Very important.